Hello and welcome to Chapter 2 Test Part 2 video. Okay, this is a flowchart proof. The first thing we always do with flowcharts is we write our given information. So right now they tell us that this line DE is equal to line JL, and that is given. They also tell us that this angle is 70 and that angle is 70. So angle E is congruent to angle J. I can use just one letter because there's only one possible angle for that, and that is given. So I need one more thing. And really what I got to do here is I got to figure out this missing side. This is 70 plus 60 makes 130, which means since I know that all the angles in the triangle add up to be 180, that makes this have to be 50. Aha! And now that gives me another angle that matches. So now I know that angle D has to be equal to angle L. And how did I know that? Well, it's called triangle sum theorem, but you could even say all angles sum to 180 in a triangle, right? That's how we know. It's not a regular triangle. And now we've got an angle that's the same, we've got a side that's the same, we've got another angle that's the same. So by angle, side, angle, we know that triangle, let's call it DEF, is congruent to triangle. The one that matches with D is L. The one that matches with E is J. The one that matches with F is K. All right. The next proof looks like this. Again, start with your given information. Here's something given. If angle DOE is congruent to angle NEO, that's given. Let's mark that. DOE, that's here, is equal to NEO, that is here. So those are equal because it's given. Now my other fact that I see is that we have parallel lines here. DE is parallel to NO. Those are not congruent, they are parallel. But if they're parallel, then I can figure some stuff out. If we have parallel lines cut by a transversal, then this angle is alternate interiors with that angle. So let's call it, I can't just say angle E because there's two angle E's. Let's call it DEO has to be congruent to NOE. And the reason I know those have to be equal is because the lines are parallel and these are alternate interiors. So now I've got two angles, I need one more thing. Aha, I have a reflexive side right here. Boop. So angle or side EO is equal to side EO, and that's the reflexive property. And that tells me that these triangles are congruent because I've got an angle, side, angle. That tells me that triangle DEO is congruent to triangle NOE. However, I'm not done because that's not what the problem asked me for. The problem says prove that this line equals that line. Okay? Well, the only way that's going to be true is if these triangles are congruent, then their parts are congruent. If these two triangles are congruent, then this side has to be congruent to that side. And the reason I know that, so that would be DO has to equal EN. And the reason I know that is because corresponding parts of congruent triangles are congruent. Once I've proven the triangles are congruent, then their parts have to be congruent. There's your proofs.